Testing, 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 testing. Good. Awesome. Who else do we have over there? Oh, Derek. So, how many of you know Dr. Vishanoff or David already? Yeah, quite a few of you. So David and I met when my wife got a position at OU, and he's also in the religious studies department. That thing is blinding me. Hold on, I gotta come over here. And so we started talking, and I was learning about what he was doing, which is sort of studying Islamic texts and Islamic hermeneutics, like study of textual interpretation, which I only learned that word because I've talked with him. And then I was telling him a little bit about what we were doing with Exaptive, and David started sharing with me I have this Access database, and I keep this structured data, and I put it in my notes in these ways so that I can run these sorts of queries. And I realized just because you're studying ancient Islam doesn't mean that you can't be using very modern tools to do so. And so we started really hitting it off in terms of thinking about the sorts of things that David wanted to do in his research, and what sort of modern tools can, what are the gaps in the tools that he has available to do that. And that started what has really been a really satisfying partnership for a few years now. He's been a guinea pig of many of the Exaptive ideas, from Zap building in the studio to different iterations of text mining, to being also our first Cognitive City matchmaking recipient. We sort of match-made a conversation with him and with, hey, welcome, come on in. You here for the meetup?
Yes.
Great, make yourself at home. And there's pizza there. If you want pizza, you can grab some pizza first. So yeah, we match-made him with Christoph Diaz, who was a geneticist, and they had a really interesting conversation, which I was able to use a year later in a TEDx talk that I gave. And David shared some of the work he was doing looking at how Islamic Psalms change over time through different translations. And Christoph said, oh, that's kind of like a species tree, a genetic species tree. And so it's just been fascinating to see, the vision we've had for Exaptive about being able to have ideas sort of flow more easily between different fields and flow more easily between different practitioners in those fields. It's just been really exciting over the years to sort of see that happen in different ways with the work that we've done with David. And then so that early work then led to him putting together a presentation of lots of different visualizations, including many that he did, with tools other than the work we did for him at Exaptive. Many different visualizations, and putting together a presentation that got the attention of the Library of Alexandria, and they kept inviting him to give a presentation. And we kept thinking about, he kept saying, well, I'd like to give a presentation, but not till we've improved the tool with these other things. So when are we gonna make this thing better? And about 6 months ago or something like that, we decided that we had the bandwidth to make the tool better. They were having a big data conference. And so Josh and whereas Kent and Jack, and we were at a number of people that helped really improve the tool. And then we went to Egypt it was a month ago now or something, and gave what was for me one of the most fun presentations I think I've given in a long time, because it was technology not for technology's sake. It was sort of technology in a very specific context for someone who had a specific need. So for this meetup, it'll be David and Josh talking about sort of a longer version of what we presented in Egypt, and one that also has a lot more of the technical expertise behind it. Josh was really did a lot of the heavy lifting on the data science. And with that, I'm gonna turn it over to you guys.
Okay, thank you.
Oh, you don't need to. Good. Go over here. Okay.
Yeah. How many of you are in
the humanities somehow? Am I the only
Oh,
humanitarian?
that's an interesting question.
How many in the arts? How many artists? I know we've got a couple of artists here.
Wait, I'm a photographer. Does that count? Okay.
We've got a few in the autumn here. How many more on the, how many software programmer developer types? Okay, but not everybody here. I've been asking people beforehand, is it data or is it creativity? Which is the driver for you? And realized at OU I get paid for the creativity, not for the data stuff. They really, most of them really don't care that I'm doing some creative new ways to do what I'm doing. Look, what I do is, well, how many of you read books? Okay, that's our entree here. This is the data set for my first big project, my 10-year project. In the Arab world, if it has to do with religion, it's got to have gold lettering. So it looks really cool. And pretty much, you know, I read about this much stuff. And it took me 10 years to get my own one book to add to the shelf out of that, right? It was an intellectual history project. The book that came out had a bunch of names in it, some of these people that were talked about in these books, quoting their views about how language works, and particularly how that means they should interpret the Quran to create Islamic law. Theories of interpretation. And along one axis, between clarity and ambiguity of language, you could plot, I kind of plotted the theme of the book. Historically, these two different views kind of moved toward each other and coalesced over time. It was an intellectual history project. Out of all that data, I ended up with kind of a map, a chronological map of ideas moving like this. That's the kind of work I do. For that project, well, you remember writing note cards? Maybe you didn't, but I wrote note cards in high school working on research papers, right? And then you kind of lay them all out, stick them in stacks, and you turn them into an outline, right? Well, for this project, I ended up with thousands and thousands of note cards. I'm really glad I thought early on to put them in a database, because that made the writing process much, much better. So I had this nice, I didn't just have pieces of paper with writing. I had, you know, name and date fields, and this person quotes this person. I had nice structured data for this, which I didn't know how useful that would be, but it turned out to be really useful. That was my first project. Now I've got my second project, got Indonesian, Arabic, and hopefully sometime soon Turkish. I don't know Turkish yet, but I've started buying the books because, and this is modern stuff. Same ideas. How do you interpret the language of the Quran? But now this isn't just happening in Arabic as it was in the 9th, 10th, 11th centuries, that first set of books. Now it's happening in all these different languages. I need to learn Persian too, not well, but enough to read some books. And you know, when I went to Indonesia, we've got a student who's scanning these Indonesian books for me right here. And you know, between the two times I've been in Indonesia, they had published another shelf worth of books on this topic. So next time I go back, I'll bring back another shelf worth of books. It's going to be I can't write note cards on all these books, right? And you've all got this problem. You've got books you don't have time to read, right? Or, as I was talking with Noel, or, you know, or just websites. You've got the web, and you want to know where do I want to go in this mass of textual data? What I'd like to do in the end is, this is from one paper I gave recently about this Indonesian thinker I'd been studying, and the connections, the chains of influence, the European thinkers, the medieval Muslim thinkers, the modern Muslim Arab thinkers, a Japanese thinker, the people who had influenced him. That's the kind of book I'd like to write in the end, is talking about these intellectual networks. So that project is going to be rather different. I'm not going to be able to sit and read all these books and write up nice, neat note cards. And that's the problem, essentially, that we've been trying to solve. How do I tackle that too many books to read problem? First, the inspiration for what we're working on now came out of talking to Dave and realizing, oh, there are digital methods of analyzing and then just visualizing data to see what you're working with that that could be useful for my work. So to learn them, I went through this database one summer, took a couple weeks, and sort of learned okay, first thing I got to run queries and I found out everything revolves around a CSV file. So I learned how to get getting the right CSV file was really tricky, out of access. Learned how to get that, and then start doing some things with those queries I ran. Here I just turned this into a text file because this particular visualization tool, the visualization of science viewer, wants text files. Here I had it spit out all the citations. A cites B, B cites C in my database, thousands of citations, and just had it cluster who cites whom, sort of weighted clustering, greater numbers of citations, larger things, and then the edges, I guess you could say, of this network are weighted, so they attract the people who cite each other most often attract each other. This one was kind of fun. This is based on my note cards. If it turns out that if these colors, it breaks them down into colored clusters based on the people that tend to cite each other the most, they almost perfectly align with classical Islamic schools of theology and law. I didn't tell it that. It's in my database. It wasn't in the CSV file. I didn't know their affiliations. It just looked at who cites whom, and it turns out they cite each other pretty much within their schools, which I would not have guessed, actually. I knew what the schools are, but I thought they cited each other a lot across schools, not as much as I thought. So those are Hanbalis up in blue. These are Mu'tazilis, Asharis, Malikis, Shafi'is, Hanafis, different schools of thought, which actually gave me a little more confidence in the tool. Like this visualization stuff isn't bunk. It's seeing something in the data that I knew was really there, and to see it confirmed visually gave me a little more confidence I wasn't wasting my time, right? This is who refers to certain topics, like the clarity of speech, the nature of speech. Like this guy Al-Baqalani here, he loved to discuss the nature of speech. Apparently also talked about some of these things, but didn't spend much time on general expressions, which was a huge topic for the medieval theorists of language. Tried some, okay. But this here is visualizing actual A cites B. That's structured data. That I'm not going to have for my new books. I would love to be able to scan all those books and find out exactly who's citing whom. Maybe next project, right? But that's going to take a while. You don't have to have structured data to do this, to gain from these tools, I found. I can just have a whole bunch of books, a whole bunch of text, and I can learn a lot. So I exported just all my note cards, numbers 3,266 through 3,299 here. Just each note card is a line of text, turned that into a text file. Treat each of my 4,000 note cards as just a single line. Treat each of those as a document. And then tell that same program to cluster the terms in those documents. And this gives me a map of, here's that, more of that image, a map of what's in those thousands of note cards. What are they talking about? So down here you got speech and meaning. There's Al-Baqalani, that same guy, right in between, right? Those were his topics. But you've got law over here. Here you've got in brown, you've got a cluster of sort of more modern radical thinkers who, are sort of on the fringe of the medieval discourse, you might say, literally. This is just the same map here, but viewed as a heat map to get a sense of which terms show up most. These are, okay, that tells me what's in my note cards. Of course, I already knew it was in my note cards, more or less, right? I wrote them myself, so this is not entirely satisfying yet. And it's not visually really helpful. But this, if you could kind of just zoom out and just get the main terms, you'd get something like this. I just told it, set a minimum threshold for how many times a term had to show up, right? And now you start to see the main topics in my notes, and actually these clusters of words actually correspond pretty closely to some sections in my book, because these are the main it's pulling out the main topics. This is something we've worked on with our program, is how do you take a whole bunch of information, a whole bunch of words that are in text, and be able to zoom in and out and get the big picture, but then go in and find details. I couldn't zoom this. I had to run separate queries for it. Because I had structured data with dates, for the dates all these people died, I could look at the main topics and which topics were most popular in which centuries, things like that. That was kind of fun. And there are all kinds of other visualizations I've played with. This is a neat online tool from an Italian firm, Density Design, where I just copy and paste in my CSV file, whatever query I ran out of my database, and then you scroll down and you pick the visualization you want, and it just plugs, you drag your fields into, okay, it's only got two kinds of parameters it needs. You drag in the fields, and every time you drag in a field, it tries to make sense of that and show you the results. You can do by trial and error. There's an alluvial diagram, which I played with a little more and got to look like this. All those names of people on the left who quoted this one guy, Shafi'i, on the right, but quoted him about which of those main topics. And those topics were discussed in which of his books, right? And I had fun. Spent 2 weeks doing this, had fun. This is just an Excel, like standard graph in Excel. I managed to get a CSV file that showed who was cited most often over the centuries by later figures. Sort of a trajectory of different figures' influence over time. You know, I'd love to be able to do all this with my new collection of Indonesian books and see who are the most influential thinkers, who cited whom, right? I'd love to be able to do that. But to do that, you have to start with structured data, with actual citations, right? And ideally, I want to do this with data I didn't write myself, right? It's not that exciting to see visualizations of my own note cards. So what if this is you? You've got a whole bunch of books you don't have time to read, and you're wanting to, figure out something like this, right? That's the problem. If you don't have that structured data and you don't know what's in those books, can we do something with that? And that's the ZAP we've come up with. I'm going to show you a little bit how it works, and then Josh is going to explain how it works. This is like the term clustering in a couple of those visualizations I showed you earlier, but way more cool. See if I can, there we go. And we'll just take you right to the live tool here. Dave let me do a live software demo in Cairo, and then afterwards told me, nobody does live software demos. But it seemed to work fine. So this, we've scanned 288 documents. We've broken the books up into chapters so far, a whole bunch of documents. The little gray rectangles on there are the documents. And then we've just done the same thing, map out what are the main words in here. Now these are in Indonesian, but I bet you can, I bet you'll find you know an awful lot of Indonesian. It's not a very difficult language here. And you can just start exploring. What's in here? Theology, methodology, hermeneutics, interpretation, ideology, revolution, right? You know a lot of Indonesian, don't you? Let me just show you one little thing, one example of how this proved useful to me. Remember, this time I don't know these books yet. I've read a couple of them. I noticed this cluster here, traditional, local, and modern. That's the word for culture. Traditional, local culture. Right over here by all these words about hermeneutics. Fazlur Rahman's a major thinker in the field of Quranic hermeneutics. You had all this stuff about the local Indonesian culture, some terms that, Belanda, that's the Netherlands, which used to occupy them. Tasawwuf is Sufism. There's a strong Sufi tradition in Java, the island I lived on when I was there, the Sufi tradition in Indonesia. So this is some of the local traditional stuff from Indonesia that, okay, it makes sense to me that they're going to be thinking about how do we take the Quran and interpret it for our local situation. In Indonesia, a lot of them do not want Arabian Islam imported to Indonesia. They want to interpret things by their own lights, right? So let's take that word local, for instance, and okay, it's talking about a lot of these same things down here, the Javanese culture, the former colonial occupiers, right? It's exactly what we thought. What we've done here is made this so we can build a little filtered subset of all these books. So I'm picking out some topics I want. Okay, got those in there. Might pick a few more terms like Sufism here. A lot of those terms are very local. Add those in. And we're going to build a little set of documents related to this theme of local culture. And then I also happen to notice, so I'll add these in too, over here you've got a lot of stuff about philosophy, theoretical, logic, argument, demonstration. Aristotle, Rushd, Ibn Rushd. Ibn Rushd is Averroes. This is probably Sina, that's probably Ibn Sina, Avicenna, right? So we've got a whole philosophy cluster over here. And of course, the main terms, documents that include the term philosophy also tend to include the terms Ibn Rushd and Avicenna. That's why they're over on this corner of the map, right? Those were two things that drew my attention. I built up this little filtered set of, a subset of documents containing those terms, and then ran this create new corpus thing. Just going to jump over to it because I ran it the other day. I said, okay, I want to zoom in on those questions a little bit more, find out what's here, and started playing around. See, okay, now I've got a more focused set of terms. Right, no, it reloaded the wrong document. Started playing around. Turns out in here the philosophy stuff is logic and stuff is still down here. I was expecting to start to find a lot of contemporary contemporary European thinkers, because I know from the one or two books I've read that a lot of modern European thinkers from Kant and Heidegger and others have been influential actually in Indonesia. Instead, the first thing I find is this guy, Shafi'i. We saw his name earlier. He's the founder of the classical discipline of legal theory, which was what my first book was about. Like, oh, what's he doing in here? And interestingly, if you look at where he is, democracy, this means the West, problems, social problems, he's in a fairly, he's not where I would expect him to be. I never did, looking around at what's in here, I never did find those European thinkers I was looking for, which was interesting. I did eventually notice we've got legal theory, usul al-fiqh, down here, interestingly, quite a ways from Shafi'i, was way up here somewhere. Quite a ways from him, not connected to him, interestingly. Anyway, day in the life of a researcher, but instead of reading through the books, I'm trying to figure out what's in them. And I'm starting to come up with a few questions, like, why are these modern thinkers not here? I did eventually find one. There's one European thinker down here, Gadamer, who's real big in hermeneutics. One European thinker, are they not that important? And why is a Shafi'i over here, this medieval Muslim legal scholar, in here next to modern democracy, modern issues like that? How is he being used to bring the Quran into modern contemporary Indonesian culture? That I'm interested in, because I know this guy Shafi'i really well. And that's not what he talks about, right? He's a 9th century figure. So I'm curious about that, and why his discipline of legal theory is down here, actually closer to the philosophers down here than to him up here. So going back out here, the last thing that I want to show you this can help with is, having explored the discourse, figured out what I think I want to figure out, I can now figure out what to read next. So there's a Shafi'i right there. I was interested in a couple of things. Well, here's the logic and philosophy people, and it turns out there's actually a book here that talks about a Shafi'i that's over near this, has a lot of this philosophy stuff in it, which is interesting. I pull up that book. It turns out it's all about, this chapter is all about the separations and connections between two things, philosophy and Sharia, Islamic law, which is a Shafi'i's domain. So actually this, if I want to figure out why Shafi'i is connected to this philosophy thing and not to his legal theory, I could start here. That's a great reading suggestion here. Or the other thing I wanted to find, where was Shafi'i here? There he is, right there. The other thing I wanted to find was traditional, local, modern culture stuff over here. Got a book called Menusantarakan, to make Indonesian. It's interesting. It turns out that's, so the books about a Shafi'i, or that talk about a Shafi'i that are over here near this topic, I'm probably going to start with those two books. Do you realize that's probably the hardest problem as a humanities researcher that I face? I've got thousands of books, or you're searching the web. You've got millions of websites. Google's showing you a list of 32,000 of them. What do you start reading with? And in 20 minutes one afternoon, I'm like, oh, I'm going to start with those 3 chapters. I would love to see this on the front end of a library catalog. I was talking to a guy at OU the other day who runs the digital Latin library. I would love to see this on the front end of the digital Latin library. When people come in, instead of searching and getting a list of books, the library catalog doesn't help me a whole lot if I don't know what I'm looking for. It just gives you a long list of books. You can only really look at the first 20 or so. And what if I could tell it, like, oh, show me what's in those books. I'm interested in this part. I'm interested in this part. Zoom me in. Help me find the books that are relevant to that. That'd be a pretty huge leap forward. And we've done it. It's magic, and Josh's going to tell you how we did it, because I'm not sure I could.
All right, we'll try. Okay, so this is what we're trying to get to. And we're going to start with a bunch of texts. So what we do first is, say we had 100 documents. We have a string that just contains the text from the entire document, or it could be a chapter. We're going to put all those into a list. So I have a list of 100 documents all together. And then we're going to go through and compute how many times do words show up in each of those documents. So for a given word, which might be, this is our first word, this could be like logic. And it shows up 3 times in the first document. Or sorry, this is our first word. Okay, logic. It shows up 3 times in this document, 1 time in the next document, 7 times in another document. Yep. Is this better? Awesome. Okay, so we've got our terms. How many times these terms show up? This term shows up in these first 3 documents. That goes on and on and on. Could be 100 documents, could be 1,000,000. And then also you'll notice that several of these cells are empty. And that's because not all documents use all terms. And that's going to be kind of important going forward because a lot of algorithms don't like that. It's called sparse data. And our data is very sparse in this case because most documents don't use most words, right? In some ways, that's a challenge. In some ways, it's good because we can figure out what words are important to those documents. So once we have the term counts, the next step is we're going to try and turn those term counts into something that tells us something about how important they are. And so we have our terms by documents, and we pass it through this kind of standard by now text feature. It's really a heuristic, but it's an approximation of an information theory idea. The standard version of it is term frequency inverse document frequency. So what they do is they say, okay, how many times does this term show up in this document? And then they basically normalize it so that if it shows up in lots of documents, then it gets penalized. We kind of rotate it, so instead of figuring out how important a term is to a document, we figure out how important a document is to a term. And I'll explain why we do that in a little bit. But if you try and visualize this, basically wherever you see this purple, which is kind of the bottom end of the range, which is 0. So this is kind of nice because it puts everything on a 0 to 1 range. The sparse data is kind of this purple, and then as they get more and more important, it gets towards this kind of yellow color. And hopefully there's a lot of patterns in there. It's kind of hard to see when you're looking at an image kind of like this. Okay, so from there, so we're in 100 dimensions, however many documents we have our 300 terms. That's, and it's sparse. Like I said, sparsity is a problem. So what we do is we use singular value decomposition to take the terms that are measured in 100 dimensions, our original document space, and compress it down so that they're in only 8 dimensions. And 8's kind of a parameter. It could be 8, it could be 20. There's kind of a trade-off there. Basically, if you have, it's kind of similar to principal component analysis, which some of you may have used before. If you have a higher number of dimensions that you're compressing it down to, you can save more of the original information from those documents, which is normally a really important thing in principal component analysis. But we're not actually trying to save all the information. We're trying to learn very high-level concepts from those documents. So in some sense, this is also helping kind of discard noise. It's a denoising operation also. And the cool thing about it is we also get a dense measurement out. So we actually have a value for each of those dimensions, those 8 dimensions, instead of the original 100 where we didn't. Okay, so now that we have that, we can cluster in that space, but we don't know how many clusters to use. So people familiar with clustering at all? Basically, yeah, you've got a bunch of points. Some are kind of closer to each other, like they're little globs, and we want them to be in a cluster. You have some other points kind of close to each other, we want them to be in a cluster. So we're clustering our terms together, and most algorithms, or many algorithms, require that you know how many clusters going in. So you say, okay, show me how the terms fall into 3 groups. And the problem with that is we don't know if it should be 3 groups or 5 groups or 8 groups. And so there's this metric called the silhouette score, which basically says, okay, if you have a bunch of points that are right by each other and a bunch of points right by each other over here, if they're really far apart from each other, those 2 groups, based on kind of how wide they are, if they're really far apart, then they're really distinct. And they'll be pushed up towards potentially as high as a 1 on that range. And if they start coming together and to where they overlap, then they can end up with actually a negative value. So it's a measurement of how good your clustering, how distinct the clusters are that come out of that. And so if you look, as you increase the number of clusters at that score, you can find these interesting peaks. This is what you look for right here. What you don't want to have happen is just that it gets better or gets worse as you go up. You want to see these interesting peaks, and those will usually correspond to some kind of meaningful distinction in your data that you found. So yeah, so basically what you can do is you can say I want to start at 2, because 2 clusters is kind of the minimum. Like if you start with 1, then you haven't really learned anything, right? Because everything's in the same cluster. You definitely want to have less clusters than however many words you're trying to put into groups, because you don't want every word to be in its own group. But you also don't want to sweep the entire range because it'll take a while. You have to cluster for every single time. Like every point there's another job you've got to do. And if you end up with 50 clusters, how are you going to visualize that with color? Because they're just going to overlap and lose the distinction between them. So in this case, 7 was a really useful number. And while we're in this space, we know we compress down to a space where we're using concepts that we care about. We also want to know what are the related terms. So when Dr. Vishanoff clicked on a term and we see the related terms, how can we go about finding those? And so the way we do that is with k nearest neighbors. So k is just a parameter. So for k of 3, we're saying for this point right here, which of these other 3 points are closest to it? And here we can see there's the first closest point, the second closest point, and the third closest point. So the points would be terms in our case. So we'd have the 3 words that are most related to the word that you clicked on. And we're going to go ahead and compute those. It's actually not too expensive to just go ahead and compute them all in the beginning, so we have them ready for when someone clicks on it. Okay, so we got, at this point, we projected our points down to 8 dimensions, and we know which clusters they're in, so we know what color to assign to them, and we know what terms relate to other terms, but it's still in too high dimensionality to actually visualize. You can't see things in 8 dimensions. So that's the next thing we need to solve. And we do that with multidimensional scaling, which falls under a class of algorithms known as manifold. Second word just escaping me. It's a presentation thing. Basically, they operate on finding data that's artificially high in dimensionality. So if you imagine in like a two-dimensional curve, you could have an S. That could just be, if you stretch it out, it could be explained on a one-dimensional line. That kind of idea. The reason why we choose MDS versus all the other different options for projecting from 8D down to 2D is because it has a special property where if a point is, say, 2 units away from another point in that 8-dimensional space, and another one is 4 units away, so it's twice as far away. If one point is twice as far away as another in 8 dimensions, when they get projected down to 2D, the main goal of that algorithm is to make sure that they're also twice as far apart in that space. So that's really important whenever we're trying to think about what does distance mean in this 2-dimensional space. There is an artifact. You can't always project things down to 2D. So if you have like a sphere, that can't be pushed into 2D. So there's some kind of artifacts that can show up. And by going to 8D versus like say 100D, again, we actually reduce those artifacts a lot. So it's again good to be operating in a lower dimensional space in the kind of middle before MDS. Okay, and then, so we've got, as we saw, we had our points, but now we need the document positions. And those are these black squares. They were the gray rectangles in the other visualization. And the way we solve for those is we know how important the documents are to the terms, and we can use those importances basically as relationship strengths and find the most important documents to each term and then use the term positions. So we've solved directly for the term positions. Now we have to approximate the document positions. And we do that by weighting the document position relative to the terms that it's most relevant to. Or sorry, the other way around. That the document was the most important to defining the term. And that's basically what it takes to make the visualization that I showed. Again, there are a lot of parameters that I talked about. Just recap on those. The features, there's a max number of terms. So in English language, people put it at around 300,000 words. We probably don't want to view all 300,000 words at once. So we have to pick some max number of terms going in. Typically something like 1,000 for a single plot, but we have gone higher before. Also, we have to filter which terms get picked. So if you're going to pick 1,000 terms, you have to decide which 1,000 terms do you pick. And we can do that based on a couple kind of heuristics that make sure we pick good words going in. One, if a term only shows up in one document, it's not going to lead to anything meaningful with this kind of an approach. So we make sure it shows up in more than one document. But you also don't want it to show up in every single document because then we can't use that TIFF-ADIF information theory approximation to pick the good ones. There's also this concept of stop words. And what that means are basically words that are used to construct sentences that don't really tell you anything about the other important words. So the, and, which, those are all in English stop words. It's kind of interesting in this project because we have to find stop word lists for other languages, which is not something they don't all just exist. Like you can't just pull those in from libraries. But it's kind of cool that TIFF-ADIF information theory approximation I showed you is a way to automatically find those. So you can use that kind of in a more simple first pass to try and find those automatically, at least for a given document set. I also want to point out, so in like Arabic, it's a different kind of problem for different languages. So English, 200,000 words, we could find all those if we wanted to. Arabic's much harder. They have something like 50 million words. So it's something to keep in mind as you go from like language to language. That's a way to run out of memory real fast if you're not thinking about that. And then singular value decomposition, I talked about this quite a bit. how many dimensions. So we start off in, say, 1,000 dimensions if it was 1,000 documents. Do you pick 100? Do you pick 20, 10? That's a parameter to play with. As I said, as you go lower in the dimension parameter on that, use higher and higher order concepts. And you also reduce the amount of artifacts you get from projecting down into 2D. And by the way, 2D is also another parameter. So far, we've only looked at things in 2D here, but 3D is also an option. You could make a scatter plot in 3D. It's just a little bit harder to move around in. And you might have things kind of like occluding your view. There's also the KNN, how many clusters. As I showed, we have a pretty good way of dealing with, that should be K means how many clusters. There's two things hiding there. There should be 2 bullets. K means was the clustering. How many clusters should there be? As I showed, the silhouette score is an approach to kind of find how many clusters you should be using. So that's handled. The other bullet point that's hiding in there is KNN, what is K? And so when you're clicking on a word, how many words do you want to find that are related to that word? In some ways, that can kind of be chosen by the end user. If they want to find 50 documents related to one, you could also find many of them and sort them and just go down the list based on, you know which one was closest, second closest, third closest. So there's not much reason to pick a really low number as long as your interface allows for you to kind of scan through them. And then relationships, how many to find and visualize. So part of that's covered by KNN with the term to term, but also for the term to document relationships, which are based on the importance values. I think that's pretty much it. We can either do some questions about that now or save them until the end. Sorry, that's it for the how. We have another section we can jump into. Probably the best thing to do. We'll come back to questions.
I can, is this thing on too? Yeah, I can help to MC some questions. I mean, I spent time in the beginning talking about, the relationship that we had with David Vishanoff, but I think you can see in this work here, Josh's contribution to this really shines, because I think, as you can see, we tend to think, I think it's easy for people to think of data science as applying an algorithm. But can you go back to your, what you can see here is that this is not an algorithm. This is a set of algorithms in a workflow where each one is necessary to sort of end up with the desired effect. And Josh has a background both in computer science and in machine learning. He's the lead of our machine learning team. And he has a background both in industry and in working in academia, and I think a Nature publication now under your belt. Congratulations. And part of what he brings to problems like this is the ability to not just think about what the right algorithm is, but to think about how he can stack multiple algorithmic approaches in a way that can get the desired effect. And so, this is something I think is pretty advanced, and part of what I was excited about for this talk, to be able to get into the technical details, because these are some of the nuance, I think, for people that are designing their own algorithmic approaches. I think this is some of the stuff that gets sometimes obscured in like the black box of the algorithm, and to have Josh sort of make that black box a little bit more translucent so we can see what's in there, it's really impressive. I have a particular vision I'm excited about with where this work can go next, but before I talk about that, are there questions that people have either for David, who I think, helped to articulate why he cares about the technology, what does he read next when it's too much, or for Josh, who sort of put all this amazing stuff together to make it work? People have questions for either of them?
We've got one over here.
This is actually maybe more towards David. I'm hoping I'm not going to sound nostalgic in this question, but way back when, I remember using the card catalog in research, and I feel like the ability I've lost something in that. when the card catalog went away, there was something that was sort of missing in my ability to find a source and then actually use that as a way to sort of spread a little bit beyond that particular source to kind of look into what else was available. And when David, when you were kind of talking about this, finding these connections, it just made me think about that. I wondered if that's ever sort of occurred to you that that maybe that's something that is missing in the way that information is presented today in terms of, when we go to the library and we pull up information and we get this list that's really just based on whatever text term that you happen to pull up. I don't know. Does that make any sense?
Yeah. No, I think what we've lost with the card catalog, I look at an OU library book today, and I opened it up, and an old card catalog card fell out. They just use them for scrap paper now to write. They just use them for scrap paper, right? What we've lost with that is that, when you're looking in the card catalog, it's organized by some classification system. So and generally, books have coherent topics, and the ones near it in the card catalog are about a similar topic, right? So if you're browsing on the shelf with that system, Library of Congress or whatever system, or you're browsing the catalog, you get the things on similar topics are clustered right near it, right? When you're just searching for the word hermeneutics, you get things from wildly different disciplines that still deal with hermeneutics, right? So if, in my case, I'm interested in Quranic hermeneutics, but I might have stuff from biblical hermeneutics or all kinds of stuff, whereas in the card catalog, I would be in the Islamic thought, in the Quran exegesis section, right? So we lose that some of that clustering. I think what's interesting about this, if you think of this as a card catalog interface in a way, is it's classifying, it's clustering things the way the classification system, but instead of having the Library of Congress classification system, you kind of get to create your own. I'm interested, I'm going to zoom in on this section of the map. I'm going to select some of these topics and look at a subset and see how they're connected, right? You can cluster in multiple ways, and you can determine the clustering yourself rather than just having some cataloger determine it for you.
So that brought back a nostalgic memory for me too. It's like my parents who are here from out of town, they, love bookstores and libraries, and so I had that experience when I was growing up of like learning how to use the card catalog, but also the experience that David described as like once I'd figure out how to go to the bookshelf, then my favorite part was browsing to the left and browsing to the right and up and down, because that was an interesting area, and I always sort of found the book I was looking for, well, if it was there, sometimes it was checked out, but if it was there, but then I would look around, and I hadn't really thought about, like, watching David use the interface was a lot like that. It was like he could go right, he could search for a particular name or a particular person, and he could go right there, but then what he did was poke around, and I think that, something I spend a lot of time thinking about is that we've tended to be excited about machine learning and artificial intelligence as ways to give people answers, as opposed to give people the tools for the experience they want to have. So there's like a different set of interfaces for just trying to give the answer than there is for letting someone explore. And I think what was so exciting to me about this project is that, all the math that Josh did behind those things wasn't to spit out wasn't to tell David, here's what the computer thinks you should read next. It was to give David the tools to figure out what he should read next by looking around. And I hadn't thought about, just watching him do that just now sort of felt like browsing the interesting part of the library. So that's cool. That seems like a success.
Ask, which was thinking like like a recommendation system. Like if you've read certain texts and you're interested in certain terms and topics, would this give you recommendations? Not just manually, but of course like automatically.
Yeah. Oh, I just were you used to like throwing that thing around? I forgot I had a mic, so I was waiting for you to throw it to me. But yeah, I mean, yeah. As we saw, you can say I want there to be 20 relationships, up to 20 relationships, or something like whatever you pick between one document and another. So if you know you're interested in one document, you can find which other documents are the most related to that and work your way down the list.
Do you have that last slide I asked you to put in?
Yes.
So,
I think Jack had a quick.
oh, Jack.
If that's.
And that's what I think is, like, just kind of building off what you were saying, I think that's what makes this really interesting is the fact that you can drill down. You can, like, in the demo you showed, like, oh, here's the filters of the things that I'm really liking. And so you're able to drill down, and then you get a whole new landscape to explore. And so, and it looks similar to your old one, like, you know, it has the same types of groups, but it's more specific. And so you're able to, you know, really get closer to what you're looking for. But yeah.
Let me get that next.
Yeah, so don't play it yet though. So I asked them to include this one slide because there was like a point that I get particularly excited about with this, and your question just sort of hit on it for me, which is that one of the main differences I think in the way this was designed was that it was, you know, I sometimes think about the difference between data visualization or data application as a television versus a telephone. So like a television is this thing that you just passively watch, you know, and a telephone you're having a conversation. And we talked about that a lot as we tried to design this because we wanted to make something that was more of a telephone than a television. And so what is it to have a conversation with this thing? It's sort of what Jack was alluding to. Like David can look at it, but then, you know, he makes some selections, he deforms the landscape. So that's more of the conversation. But then the next question is like, how can that conversation benefit other people that are sort of having their own conversation with their own documents? And I think that's really where like a recommendation system emerges. You know, Netflix recommends things because other people watched it and stuff like that. So where I'm excited to take this next is this idea that we can take metadata from how people use tools, and we can use that metadata about how they use the tools, the way that they converse in those sort of telephone interfaces. We can take that metadata to start to connect people to each other or to connect people to other things. So this visualization here is what we spend, you can play it now. Yeah. You know, we spend a lot of time at Exaptive trying to take networks of people and thinking about how we connect those people together through connections that are different than just social connections. It's not who they know or who they want to, you know, share photos with. It's sort of connections about the work they do. And so imagine if these purple nodes were particular terms or documents or subsets of groups that people had worked with in those different interfaces. Where I'm really excited about taking this next, and you know, we as a company, we always have to find like sponsors for the work that we do. So if anybody knows who wants to like fund this next phase of work, let me know. But you know, where I want to take this next is by thinking not just about a single researcher like Dr. Vishanoff, you know, interacting with his landscape, but many, many parallel researchers that are all maybe starting from the same landscape, but then they're transforming it. And then as they do that, they're basically telling the system what's important to them. The same way that Google can do these like crazy autocompletes now because they know what people, you know, you type in why is the, and it says sky blue, you know, and it's like, wow, it's like it's learned. And so if you could do that with these sorts of termscapes, if you find that people are sort of focusing on the philosophy and they're focusing on local and things like this, you can now start to connect thought partners and say, oh, Dr. Vishanoff, you were looking at this part of the landscape, and here.
Jump right off of that, because so for me, I'm a climate scientist researcher, and the number one thing I saw with this is that I have roughly in the tens of thousands of journal papers, scientific journal papers on the topic of climate science in any realm. And every week there's another 50 to 100 papers that come out in all these different, you know, journals. And just on if I have a very specific topic I'm looking at, if you start out as a grad student, like, do a lit review. And so when I see this, it's like, how do you go in and find the most important journal papers of those 20,000 papers? So that's really cool. I like that. My question would be more along the lines of, so someone that's actually has been here for a while and has a certain topic, you find the papers you want, but every week another 50 come out. So I get bombarded every week with emails that say, oh, here's the next 50 papers that came out. Is there a way to use this to not only find the important pieces to know which papers to read, but then also find this week 50 came out. I was at a conference somewhere else for the last 3 weeks. I don't have time. What should I do? Is there a way to include, because they're brand new, so they're not going to be cited by other people, but they're all tied to the same network?
Yeah, actually, there is a way. There are a couple places in here where it gets pretty expensive for a very large document set to put everything through. Like, we worked with one, I think the largest was 10 million documents, and that gets really expensive for some parts of this. And so it became important to be able to pick a representative set, learn a model, and then apply that model to the rest of the papers. And so I think the same thing could be used for what you're describing. You would use the papers you have, you learn the model, and then as new papers come out, you apply the model to those papers. And so that they get the documents and the terms get projected in that space. Yeah.
Cool. And I would add to what you said, like that's a perfect scenario where if there's all these researchers above us, early career people, and if they were on that link and you saw all the major papers that they were working with, you could automatically go and say, oh, it's already learned. I don't have to go and recreate the wheel. I can see what people in my specific area of the field are researching. Let's find those papers first, as opposed to just starting from scratch.
I really like this idea of the temporal component that things are coming out. We've used the term, we call this a termscape, and we borrowed that from landscape, and we really wanted to, and David, this goes back to when David first approached us. He was like, I want a map, just like a geographical map of the discourse in my field. I think it's really interesting to think about how to show that map is changing. How can you show that melting ice caps and changing geographies? You should help us think about how we convey, the changes in the landscape. Like, oh, this division is becoming more distinct, this mountain's getting bigger, this is fading into obscurity. I think there's an aspect of how do you compute that algorithmically, but then there's another really fascinating aspect of in the visual interface, how do you convey it?
Can I just add one other thing? So there's the big picture. How do you include time in a landscape, right? That's important. But even with this simple thing we've got, I didn't show you that I uploaded some metadata about my 288 documents, and I could have put in that metadata publication date, right? If you're running this off of PubMed or some scientific thing, you've got the metadata, right, including publication, and we can just incorporate very easily, relatively simply in here, just filtering by date range. And you say, just show me the last month or something like this. And it highlights those things. And you can bring things into we've got a fixed term map. You can bring new documents into it. You don't have to recompute the whole map, right? You can place those documents on that map and say, show me the last month and show me where they are in this map. You're already familiar with the map, and there you go.
Yeah, we're using color in the map to show the clusters, but if you could toggle that, and so all the old stuff becomes gray, and all you're seeing is the sort of red dots. Here's the new stuff. Here's where it landed in your existing termscape. That would be cool. I also know that we've been working with Dr. Vishanoff for a long time now, because he's starting to say, oh, and this would be easy to do. We would just da-da-da, because that's, I always drive my team crazy by saying, here's an idea. It shouldn't be that hard. Let's just do it. So thank you, David. Yeah.
Yeah, I was kind of focused on the temporal component as well. And when you first started talking and you kind of showed the landscape, it's easy. There's a way to kind of identify the major influencers, and major influencers can be forces for innovation or actually forces for stasis. So the temporal component would be to kind of map that over time and to lay on that map kind of when do we see conceptual revolutions, and to see whether there are any interesting patterns in the graph. So that's one thought that occurred to me. The other thought that occurred to me in terms of the temporal component would be there's, there can be interesting reasons why areas pop up in the map and receive more attention. And it might be interesting to kind of map, even in climate science, some of those reasons are outside of the science. It's just the society there are motivations within society that drive some of the research that we do. I think about AIDS research that relates to retroviral research. 25 years ago, if you look for retroviral research, it would be a tiny little blip. And as soon as the AIDS epidemic hit, that blip would have grown massive. But that growth was not necessarily driven solely by the science.
Next is, how do you make the user aware of the filter bubble that they have created for themselves? Because that happens with Google all the time too, but you're not really aware, obviously, of the internals that went into showing you those results. And I think that part of that interaction has to be like an honest discourse between the software and the user of, you're being shown this because of X, Y, Z.
That's a great question. You have thought, this is a challenge. We talk about this a lot, and one of the ways we've tried to help with that is sort of through a brute force approach, which is, at least we're now showing 100 or 1,000 or 10,000 documents instead of the top 10. So it's sort of less filter bubbly just in the nature of it. But can you go back to the live tool? Do you have the live tool?
Yeah.
Right. So if you click the hamburger, put all these sliders in, and they're a little bit obscure. They're obscure in two ways. One, they're like literally obscured when you close the sidebar, you don't know what they are. And two, they're sort of obscured because we're saying like SVD dimensions, and David has learned like how these sliders work. But I think it's a really interesting question in terms of like making this more accessible to a broader and broader user base, how to help them understand, either through the corpus they've selected or the parameters that they're using, to help them understand that even that is like a somewhat limited perspective. I don't know, like David, as you've used this, do you have thoughts about ways to convey that?
Ways to convey how these particular parameters are going to...
Yeah, or help people understand, like if someone's in the map and they don't find a word, for example, it could be that word isn't in the corpus at all, or it could be that word isn't there because...
It's in 90% of the document.
That's right.
Yeah.
That's right. And, did you sort of run into that issue of sort of like at certain points getting lost? Like, why is this landscape the way it is again? Or how,
No.
Yeah.
Well, two thoughts in response to the question. One is that in terms of getting out of my filter bubble, this is actually a big step in the right direction. When the first visualizations I showed you where I had written the note cards, I was finding more or less what I was expecting, gaining some new insight, right? But here, I've got a much bigger data set. It's still not going to be like representative of contemporary Islamic thought. There's still going to be blind spots in the data set, right? Just like you're searching on the web, you've only got what's out there, right? You don't know the blind spots that aren't there. But it's already a much bigger data set. And remember I was saying, like, I was looking for those European philosophers, and I didn't find them, right? And I was thinking Shafi'i would be over here next to this when he found it, but he was over here next to modern democracy. And what I have found most productive in this is not when I find what I say, oh, that makes sense. That reassures me I know what this map is about. It's when I say, wait, that doesn't make sense. And those are the documents I went and tried to read. So actually, the way this is functioning for me is it's the surprises in the interaction that are really helpful that way. There's another level too. So, yeah, so when I don't find a word, my goal isn't to get it in there. I think that's productive, actually. At another level, if you look at that last little visualization about how we connect at the meta level, how we connect users of such a thing, ideally, those users, you've got a kind of network there that's going to have its own little bubbles, right? At this point, we would just love to have bubbles, right? We would just love to have people connected enough that they're forming a community. That will be how to get them out of that community and to think, well, part of the goal will be to connect them not just based on they're all reading books about Quranic hermeneutics, but they're reading books about very different things but still focusing on certain terms, or they're taking certain approaches to their data, how to connect them across those bigger things to get them out of their academic bubbles is a really interesting challenge. I know Dave has some thoughts on. Yeah.
It's the same thing kind of struck me that you just discussed there, that what was interesting were the things that deviated from what you expected. Yeah. And in fact, when you were talking about that, what occurred to me is that this tool is useful for somebody that knows nothing. As you said, like sort of an entree to a card catalog in a library. Here's the topic, what do I read? Because I can see the connections. But it's immensely powerful for somebody who thinks they actually know something, because they can come to this system and figure out and identify things that they don't expect to see.
Yeah, it's, when I look around a map like this, I see local Indonesian culture. Philosophy was a bit of a surprise. Local Indonesian culture, hermeneutics, certain names I expect to see. And then I see, like, children and families. And why is that on here? Right? And it turns out there's a good reason. And I can go find books over near that and look at them and see what's going on. But it turns out, okay, I could give you an explanation for why that would be relevant here. But it's those surprising things. They're things I don't know to include in my book project. And this brings in more than it excludes, I think.
Yeah, I think that's a point that, like, when David first came to us with this project, one of the ways that he articulated it is, when I go to do a search, I have to start with keywords, but I don't know what I don't know. So I search for the keywords, and how can the search not just give me results, but how can it tell me these are the other words that you're not searching for, but you should? And I think that's, for children, so I don't know what's behind that story, but, the fact that children show up and that then he can figure out why, and then say, oh, well, maybe I should start including children in my search because it actually is part of this, dialogue. So I feel like, but I sort of keep coming back to what I think, like, the answer to your question about the filter bubble right now, to me, feels like the way we're trying to deal with it, is by just showing a lot more stuff in an interface where someone can actually absorb it. And I think that in some ways that's effective. Like, that's part of what the filter bubble is you just have blinders on. And in other ways, it's a little bit, crude, like it's a brute force approach. But I think it's a good start, and I think it is something, like, I think the attempt to try and widen, escape the filter bubble, I think is interesting. I found myself, people have used the term filter bubble a lot recently in the context of fake news, and you get your Facebook profile and then you just get all the news that speaks to you and vice versa, and I actually just found myself wondering, like, if we fed in, now that we have this tool, you know, if we were to grab like, if we were to take some sort of like liberal person's Facebook feed and take the 100 news articles that that person gets, and then take a conservative person's Facebook feed and the 100 articles that that person gets, and then throw those 200 text files into this, would it, with the whole point being that like those 100 things are sort of the filter bubble, would this help? What would we see? Would, you know, I'm sort of curious, would it help to illuminate like the discourse? Would it help to show how partisan it is, or would there be things that we wouldn't expect about what, you know, I don't know. There's some startups right now that are getting funded around using data science to combat fake news. And I sort of wonder, you know, if there's a role for things like that, because they help people see outside the filter bubble. I don't know.
A comment right there. I wrote that down about 20 minutes ago. Same thought. I think we should do it no matter what. But what I thought about with this slide, or this specifically, it reminds me of like an uncertainty analysis. And so like what I would do is take every single slide and see, if you go left and right, first of all, see which ones on the left have the biggest impact on changing the results. And then you can also go the reverse and say, of every single term, which of these actually impacts it the most. You can go both directions, and that would be useful for using this technique in other applications that have nothing to do with this, because you might find something out about, well, the SVD analysis is the most important. Anyway, that's the first thing I thought of when I saw that. But do the political thing. I think that's perfect.
Anybody else have any questions or comments? Or?
I've got one
Are
other
you going to
comment.
ask your 97? Okay. Good.
One other comment I'd like to make about the time dimension to this. If I think about my work trying to write an intellectual history, adding a time dimension to how we're exploring this data is absolutely crucial, right? And it's not that far conceptually down the road from where we are. The other dimension that could be further down the road but really valuable would be to recreate the kind of this person cited this person. Not just these two people used similar kinds of vocabulary, but this person cited that person. And that allowed some of the network stuff I did in my own visualizations where I had that data. But you've told me about entity extraction, right? If we can sort out, oh, these terms are people, this is the same person, this person, these are abstract concepts, you get some conceptual taxonomy of concepts, like one of the guys at the tech conference was talking about, and you do some entity extraction, then you might be able to start mining, well, this person is actually referring to this concept, and this person is citing this person about that concept, and creating out of the full text data, creating some structured data, really. And that would be, besides adding time, that would be, you know, a long-term, in terms of what I'm trying to accomplish, and what a lot of people would be trying to accomplish, I think really valuable.
Yeah, that's a good point. It's something we talked about, you know, we've talked about over the course of the project, but as another sort of layer, like, so the time layer being one thing, but then, you know, right now this is a map of terms and it's a map of works, but it doesn't have people on it. And I think that one of the things that I'm excited about in terms of the way Josh set up the algorithms is, like, there's no reason, it should be easy now, to superimpose people level of granularity, which is, you know, can you also start positioning some of the key entities that get discussed in those things? And what I like about this is, I think that the sort of map paradigm has a lot, it gives us a lot of room to grow the functionality. The same way that on Google Maps, you can put on the street view, you can put on the terrain view, you can put on the traffic view, you can sort of superimpose these different and we'll try and, it would be nice if 6 months from now or next year we get to do another tech talk on the Termscape, and it's got new layers added to it to discuss. You gonna do okay?
Oh, yes. I talked to Dave a little bit earlier because I had this question.
This is a doozy of the question.
So everything that you talked about is about the importance of a word. So finding, is it important? So the question I've been thinking about is, can you then, besides importance, can you find out anything about the meaning of the word? So the simplest would be positive or negative, right? A word doesn't mean positive or negative. So my climate science background, and this goes into the temporal too, because I'm thinking in the 1800s is when the paper started, and they were hypothesizing climate change and humans would have an influence. And so I'm imagining a plot, which is the top is yes, the bottom's no. And you have this scatter plot of all the papers that come out in time. And so each paper would have a yes, humans are causing or at least influencing climate change, or no. And so over time, visually, you can draw it out to where it kind of scatters, and it comes up and it goes to a yes. And there's been papers out now about the 97% of scientists. And I've discovered that that's based on it's not mind, it's actually people physically going in and reading and trying to figure it out on tens of thousands of papers. So this is actually a project we can do, because I've talked to people that want to do this, if we can figure it out, to go in and just mine all tens of thousands of papers and find out the exact percentage, first of all, which we know is high. But the more interesting thing is to watch it in time. And so could we go in and identify a yes or a no? Because you could see, like, even in the 60s and 70s, there was fights whether sulfate aerosols going up would cool the earth or greenhouse gases would warm it. And there was a scientific debate, and roughly 30%, 20% papers came out that said, I think we're going to cool. And that was the big Time magazine article that said, we're going to an ice age. And it said all climate scientists said yes. And now it's like 10 to 20% of the papers we're discussing, and it's completely legit, and it's all scientifically accurate, and then the science, just tens of thousands of papers later. So this is the climate science version, but I could see it happening elsewhere, like cigarettes. Do cigarettes cause cancer? You could follow the evidence, and if you could create this metric, then you could enter the policy debates to say the science actually is at a certain level based on this algorithm. So is that possible?
I want to try and paraphrase this and see if it's an accurate paraphrasing before Josh then tells us how he's going to solve this problem, which is that so Josh talked about how, when he was talking about singular value decomposition and stuff, he was sort of saying, oh, you worry about going from these discourses at a very granular level, at a somewhat granular level, can we figure out a consensus, what's the consensus model? And at this point in time, we're 60-40, and the next point in time, we're 70-30. And so, Josh, what do you see, in terms of, that does sort of move from the exploratory interface to more of the computer giving us an answer, just tell me, right? Yeah. And do you think we can? There's been a lot of work on sentiment analysis and things like this. If we were to put in climate science papers into this and add some more intelligence, do you think there's a path towards it telling us 97% of scientists think there's climate change?
Possibly. I think a couple of thoughts about that. Yeah. So that kind of thing's done with like the more serious, I think, stock algorithms right now. Like, it's hard to predict the future, but it's a little bit easier to kind of catch news articles right as it happens and then ride that wave. So they do the same kind of thing. I'm not sure. So you can't just look for probably positive and negative words. It's probably something a little more sophisticated than that. That's what we need if we went along the same lines. So we could build what's, in that case, would be more of a considered supervised learning problem. So it's a supervised classifier, and yeah, that could be done. I like, if people have been tallying them up already, that might be useful for like a training set. So we might be able to piggyback off that. So that's one route to go. I kind of like the idea too of if you just crush this dimensionality down to like 2 dimensions, something like that, trying to find the really polarizing ideas and trying to understand what those are. That's interesting. Like, you wouldn't necessarily find yes or no, like are they saying it's going to be cool or not, but it would be interesting to see what's kind of like the most polarizing concept in those papers.
Before all that even, so what I've realized is that I get X number of journal articles that come to me, but every single scientific field talks about climate change. And so we don't realize that, an ag paper or a ecosystems paper is actually talking and agreeing with everything in a certain concept, or if whatever I'm researching, if it's drought, these 50 other fields could use my work, but I don't know it. So the first step is just, this is perfect for going in and saying, go to every journal paper that's published in the world, find me the ones that are talking about drought. So I already see that as the first step, but the second step is to keep going out to all of those.
I just had a comment that the extrapolation idea might in itself create a tipping point, so that we increasingly see in America where more and more parents say, oh, I don't need to vaccinate my children. Now, it's only a small number right now, but it's an increasing number of people are not vaccinating children. And then suddenly, if polio and smallpox reappear, there's going to be a massive change, I would think almost instantly, of the government making laws about vaccination and whatever. And so you're going to invert the curve because of the consensus that led to lack of vaccination.
I wonder if,
Yeah, so I was thinking of it as a supervised learning issue. I mean, you would like to learn what does a positive paper look like, and then find others, and what does a negative paper look like. But what's interesting is finding the papers to support the negative now would be hard, much harder.
Yeah.
So getting that training set's going to be hard, but it would be really interesting to know what that training set looks like now, when it's hard to find, versus 40 years ago, when it would have been more equally split.
So I was mad because when I found out the 97% wasn't all 20,000 papers, it was just